Hello friends, welcome to my channel OMSR Academy. In this video, I am going to tell you about how to solve linear equation using Cramer's rule using MATLAB. So before going to the MATLAB program directly, I am starting with the basic concept. Okay. So to explain how to apply this Cramer's rule in the linear equation, I will take the basic general expressions, general linear equations. Okay. So let's say I have linear equation a1, x1, b1, x2, c1, c1, x3 equal to b1. Next equation, let's say it is a2, x1, b2, x2 plus c2, x3 equal to b. Third equation, let's say it is a3, x1, b3, x2 plus c3, x3 equal to b3. So let's say I have three equations and I want to find out what is my x1, what is my x2, what is my x3. So this I want to solve using Cramer's rule. So first step, what I will do, I will write I will convert these linear equation into the matrix form. So let's say I am taking one variable named a and I am writing this in the matrix form. I am collecting the coefficient from each equations. Like first equation, coefficient is a1, b1, c1. Second equation, a2, b2, c2, a3, b3, c3. So this is my matrix. And then I will write the source vector, whatever be the coefficient or constant available at the right hand side, I will make a vector. So all the values I will write like d1, d2, d3. So you have the matrix vector form. So once you have the matrix form, then you will, in the first step, step 1, you will determinant of matrix A. Determinant of matrix A. Determinant of matrix A. This is my first step. So how to find the determinant? Let's say determinant is D. The determinant A is equal to. So I will in the determinant, in finding the determinant, I will start from there. I will take the first coefficient a1 and then I will do cross multiplication between this. So b2 c3 minus b3 c2. Then I will take this b1 and it will be minus. And then I will take the cross multiplication of this a2 c3 and then a3 c2. Then come to this c1. Then cross multiplication a2 b3 minus a3 b2. Like this, you will solve the matrix for finding the determinant. Then you have to check, second step, check whether determinant B is equal to 0 or not. Okay. So in the Cramer's rule, if B is not equal to 0, then you will proceed. Otherwise, you cannot apply the Cramer's rule. So the condition for applying the Cramer's rule is you should have a linear equation whose determinant should not be equal to 0. So if it is not equal to 0, then you have to apply the Cramer's rule. Okay, you have to remember this one. Then step 3. In this step 3, you will take the source vector column and then you will replace in this matrix one by one. Okay. As here 3 variables are there, x1, x2, x3. So you will replace this column 3 times. Okay. So one by one I will write the I will uh, put my this source vector into this matrix A, and then I will write the dx. How to write it? Just to look here. So you will replace this line column A1, A2, A3 with the D1, D2, D3. This will be for the x1, and then you will write D1, D2, D3, C1, C2, C2. So you see here, you have now new matrix. If you are replacing column 1 with the D1, D2, D3, you are now having the new matrix. Similarly, you will form another matrix dx2 by replacing the second column. Means you will replace the B1, B2, B3. The first column will remain same, A1, A2, A3. Second column you will replace with the D1, D2, D3. And third column will remain same. Similarly, you will prepare another matrix dx3. In that you will replace the third column. So first column will remain same, A1, A2, A3. Second column will remain same, B1, B2, B3. And third column will replace with the B1, B2 and B3. So you make 3 new matrices corresponding to x1, x2, x3. Then you apply the formula for x1. You will apply determinant of the dx1 upon determinant of A. So each matrix you will calculate the determinant and then you will do division. For x2, you will take determinant of the dx2 upon determinant of the A. X3, determinant of the dx3. So formula for determining the determinant is same, only the values will change. Okay. So how to apply? So one time I showed you. So like this you will get the solution x1, x2, x3. So let me take one example. I am taking example to explain this. So I am writing one equation. Here you will have the values, coefficient values. 2x plus y plus z equals to, let's say it is 3, then x minus y minus z equal to 0, and then x plus 2y plus z equals to 0. Let's say these are my 3 linear equations given, and now I have to solve for x, y and z. Okay, so first step I will apply. I will write the coefficient. So instead of this y and z, I can take x1, x2, x3. So let me modify this equation in terms of x1, x2, so that it will be easy for me to write the MATLAB code. So I am writing same equation. I am writing in terms of x1, x2, x3. So this 2x1 x plus x2 plus x3, x1 minus x2 minus x3, x1 plus 2 x2 plus x3. Let's say this is my these are my 3 linear equations that I want to solve for x1, x2 and x3. So what is the first step? First step is to get the matrix. So I will collect all the coefficients of the left hand side. So first coefficient is 2. Here it is not mentioned any number, so by default it is 1. It is 1. It is 1. It is minus 1. It is minus 1. It is 1. It is 2. It is 1. So you see how to collect the coefficients and form the matrix, and then form the force vector. It is 3, 0, 0. In this way, I will get the matrix form and then I will solve it. So step 1 I said, you will determine the determinant of the A. Determinant of the A. So if you will solve it, so just for verification I am solving here. It is 2. 1 into minus 1, it is minus 1. Minus 1 into 2 is minus 2 minus plus 2. I am applying the formula directly here. Next is minus 1. Then 1 into 1, 1. And minus 1 into minus 1 is plus 1. And then 1. Then again I will do the cross multiplication and I will subtract 2 minus minus 1. Is plus 1. Once you will solve it, it is plus 1 means 2. It is plus 2 minus means 0. And it is 2 plus 1, 3. So answer will be 3. So you see here, step 2, I will check whether determinant D is equal to 0 or not. So here D is not equal to 0. So you can apply Cramer's rule. So step 3 I will apply. So I will generate dx1 by replacing this first column with the 3, 0, 0. It is 1 minus 1, minus 1. So once you will solve the determinant for the dx1, so simultaneously I am writing the determinant. It is 3 minus 1 minus 2 into minus 1 minus 2 minus plus. Here I am applying directly. Next is minus 1, and then once you will apply cross multiplication, it will be 0. Plus 1. Once you will cross multiply, it will be 0. We have the minus 1 plus 2 means 1. That means we have 3. Similarly, we will write the dx2. Dx2 will be, we will replace the second column and first column will remain same. So let me write in the next slide. So dx2 is 2, 1, 1. Second column we will replace with the E vector 3, 0, 0, and then 1 minus 1. 1. Plus 1. I am solving the determinant for the dx2. See, it is multiplied with the 0 is multiplied. It is 0 minus 3. Then 1 minus 1 minus means plus 1. Plus 1 and then multiplication of this cross multiplication is 0. That is 3 into 2 and this is minus. So answer is minus 6. Similarly, dx3 2, 1, 1, 1, minus 1. Now I am replacing the third column 3, 0. Now solve the determinant. Solve for the determinant. Here I will take 2. Once you will do cross multiplication, it is 0 minus 1 Cross multiplication is 0 plus 3, and then it is 2 minus minus 2 minus minus in 1 into plus 1 is minus 1 and minus minus plus. It is equal to, this is 3. These are the 3 determinant I found for the. Okay, now calculate the x1. So x1 was determinant of the dx1. Determinant of the dx1 upon determinant of the a. It is, so dx1 was my 3 and determinant a was my 3. So it is 3 upon 3 is 1. X2 equals to determinant dx2 upon determinant a. dx2 is my 6 and determinant a is 3, so it is 2. 2 completed. Now x3 determinant dx3 upon determinant a. If we put the value, it is 9 upon 3 means 3. So x1, x2, x3, you see what will be the value of x1? 1, x2 is 2, and x3 is 3. So that answer should come. So I did this calculation for verification on the MATLAB. So let's see the MATLAB program. So how to write the MATLAB program? So for MATLAB program, in the file, you will start with the command solve linear equation using Cramer tool. So this is my heading. I am writing in a command form. Okay, and then first step is to get the input. So you need a coefficient. So I am writing a variable name a, and I am using command input. I will show you how to write the program on the MATLAB also. Let's see the line statement, what statement you need, and then you will write input command and then bracket. So while before writing the coefficient, I will display one sentence so that you can understand what it is asking. Enter the coefficient of a. So like this information will display on the screen. So you can understand that now you have to input the matrix A coefficients. Then B equal to, again you will use command input and it will display the message. Enter the source code. Source vector. This statement will display as it is written in the single quote. Then I have to find out how many variables will be you will get for a particular matrix. So I will find out the length. So I will save this information in the variable capital N, and this will decide how many output variable come out. So I am using the command length, and this B length will tell me the number of variables you are calculating, and then you will initialize the x. So for x is the output variable, so you will initialize the x with the command 0, and it will be the length of the b. So it will generate the vector with the all zeros. So all statement I have to terminate with the semicolon. So once initializing is done, then you will find out the determinant of the a. So determinant of the a I am saving in the variable d, and the command for determinant calculation in the MATLAB is det. And if you will write this det bracket a, it will automatically calculate the determinant that I did using hand calculation. as you know, we are modifying the matrix to get the dx1, dx2, dx3. So I am using the same matrix A for saving the dx1, dx2, dx3. So before to save this original matrix, I am using another variable called A old. So this A old will retain the original matrix. Okay. And then, as I said, you have to first check whether these linear equation you can apply Cramer's rule or not. So you will use command here. If t is not equal to 0, if t is not equal to 0, then it will apply the Cramer's rule. For Cramer's rule, you will first create the matrix. So for matrix, as you know, it depends upon the number of variables. So I will use the for loop for I equal to 1 to n. In this way, I will change the value incremented by 1 automatically, as I am not showing any increment. So automatically it will take by default increment by 1. And then it will calculate my matrix. New matrix dx1, and it will save itself in the A. So I am saving the vector into the column, into the particular column. So if I is equal to 1, so here I will be 1. So your B values will save on the column number 1. If I equal to 2, it will save in the column number 2. Like this, it will vary. So once it will replace this B into the matrix, then it is, then you will calculate the xi. So xi, what is the formula? It is the determinant of the new matrix, the determinant of the new matrix upon determinant of the original matrix. So determinant of the original matrix, so I already saved in the variable b. So I will write here b. Okay. So once this calculation completed, then again I have to obtain my original matrix. Because again I have to apply the I here, and I have to generate the new matrix. So I will again save the original matrix into the variable a. Once it is completed, then I will end this. So once this completed, calculation completed, then I will display. And so for display the output, I will use command disput and then write the statement. The solution is the solutions are because you will get x1, x2, x3, 3 values you will get. That is why I am writing the solution are, and then it will display the value x. Okay. So once this output will display on the screen, you have to write the first case. If d is not equal to 0, that means else. So in case of d is not equal, d is equal to 0, then you will display something. So I will display the command, the sentence or the message on the screen. The Cramer's rule is not applicable. Like this message will display on the screen if my condition is not fulfilled. It is not applicable. So let me write it clearly here. Then bracket and then semicolon. So now if for is ended with here, and if it should also be end, so I will write here end. If command I am ending here, for command is already ended here. So this is my MATLAB program solving the linear equation using Cramer. So let me show you on the MATLAB software. So I'm showing you the program here now. So you see here, this is the program. In this, I wrote A equal to input, enter the coefficient of matrix A, single quote, and then bracket, and then semicolon. B, input, enter the source vector, then n equal to length b, and then x equal to 0, then comma 1, d equal to determinant a, and then a whole equal to a. If d is not equal to 0, then for I equal to 1 to n, and a semicolon comma I equal to b. Like this, I wrote the program here. The check. Now first I would like to verify whether this code is working correctly or not. So whatever with the hand calculation we did, we will verify. So first I will run this program and I will see how to enter the values and how to see the output. So my output is coming same or not, that I will check here. So I am running this program. So while running this program, now it is showing enter the coefficient of matrix A. So I have to enter the values. Simply you will enter the values row wise. Row wise, in the row, each element you will put one space. So like I am showing in the given example, I said to you 2x1 plus x2 plus x3. So I am taking coefficient at 2, 1, 1. So this is my first row completed. Then I will put column. Then next row I am writing 1, minus 1, minus 1. Then semicolon. Next row 1, 2, 1. So now all three rows entered here. So I will put bracket. Now enter. Now it is asking to enter the source vector. So source vector, you see, it was a one column only. So I will use the constant that was on the right hand side. It was 3, and then as it is the only one first column, so you will put the semicolon, then 0, semicolon, then 0. So this is only one column, and so you will write 3 semicolon 0 semicolon 0 and then enter. So once you enter here, you see it gone through the program. So you see here, first statement I wrote n equal to length b. So you see it given me calculated value and it is equal to 3. Then x. So initialization of x as zeros vector. You see all elements are 0. Then determinant of the vector matrix A. So you see it is 3. It is same we calculated earlier. Now A old. So the matrix, original matrix is saved in the A old. And then you see it is showing me the answer 1, minus 2 and 3. And you see it is same as I showed you previously. So let me show you the result we calculated. Here you remember that it is showing 1, minus 2 and 3. And let me show you the calculated values. The calculated values you see here. It is okay. I missed here this minus. So it is minus 6. So this is manual mistake. It is minus 6 by 3. That means it is minus 2. So you see correct answer is coming using MATLAB Program. 1, minus 2 and so I hope everyone understand how to apply the Cramer rule to solve the linear equation. Thank you for joining.